Welcome to the Contagious Code Podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, I'm joined by my friend Artem Zakharchenko. Artem is an instructor with the Epic Web program started by Kenzie Dodds. Artem teaches the world about the joys and benefits of automated testing and is also the author of the popular open source library Mock ServiceWorker, which has honestly been revolutionary in testing network-dependent activity. Mock ServiceWorker uses the ServiceWorker API to stub network requests and assert what you expect. There's inherent complexity in using something like Mock ServiceWorker at Node.js because ServiceWorker is a browser-only API. In our discussion today, we go deep on testing, automatic testing, mock service workers, mocking, the balance of being a full-time open source maintainer and having a life, and everything in between. We also talk about the Epic Web program. Look, this is a really deep dive on testing, on mocking, on mock service worker, as well as a personal approach of like Artem's own fear getting into testing. Many of us are afraid of testing, and Artem talks to that. And he also outlines ways of working, protocols for like, when is the best time to test? Should you do everything test-driven, so write the tests first and then write the features? Or should you maybe start with a bare bones implementation, make sure it's working, then test it, etc. So lots of takeaways here. I hope this helps you as it has helped me. I've been looking forward to this for a while, and I can't wait to see and hear about all that you enjoy from this discussion with Artem. Now, I'd like to offer this to all of you at no cost, but this is separate from all my other work. And the reason we can still have this discussion is because of sponsors. So let's take a minute to acknowledge them. And if you want to sponsor the podcast, do reach out. This episode is sponsored by Code Crafters. Code Crafters has an approach to learning and teaching very similar to this podcast. My most popular talk ever is called Deconstructing React, where I teach React from scratch. Literally, we don't import it, but we just implement it against like undefined errors. And so we build from scratch to learn. Code Crafters teaches you how things like Docker, Git, etc. work by having you implement this stuff from scratch in a language that you know, TypeScript, Go, Ruby, whatever. It's normally free. There is a free tier, but there's also bonus features that you pay for. And in partnering with the Contagious Code discount, they offer you a 40% discount. So if you want to take advantage of that, go to tej.as/codecrafters. That's tej.as/codecrafters. There's also a link in the show notes. This episode also this podcast actually is partnered with That Conference. And That Conference is happening in Wisconsin. We'd encourage you to share this episode on your social media if you want to enter a chance to win. And we do have 5 free tickets to give away as well as some discounts. So if you want to do that, we definitely see your shares, especially if you mention like I'm doing this for that conference, and then we'll reach out and give you some tickets. Finally, I'm thankful you're here. And now for my discussion with Artem Zakharchenko. Artem, is it Artem? Is it Artyom?
Yeah, it's Artem. Yeah.
It's Artem. Dude, nice to have you on the podcast. Thanks so much for coming and making the time to chat. I'm so excited to talk about so many things. MSW, Epic Web, testing. You've been so active in the community, so I'm really excited to get into it.
Me too. Thanks for inviting me.
Maybe we can start by just doing a bit of an intro to you for the listeners so that they can learn your background, what you're about, and what you're currently working on.
Yeah, sure. So, hey there. My name is Artem. I'm a software engineer. I've joined Epic Web just recently to be in the row of the instructors with Kenzie Dodds and a bunch of other wonderful people. And my mission is to teach the world about automated testing.
Automated testing. And Kent has been on the podcast before. Right. We love Kent around here, and he's just such a joy. So your mission is to teach the world about automated testing. And I can see now why you would have this synergy with Kent, because Kent created the Epic, no, it's not Epic, it was Testing JavaScript course a long time ago. Kent pioneered the testing trophy when there was the testing pyramid. Kent has been so active in the test space. I think, Kent also created testing library. It was first React testing library, now it's just testing library. So you're sort of carrying the torch forward there. Where does that mission come from? Why is testing so important? Is it because nobody's doing it? Is it because we care too much about code coverage? What's the take there?
I think for me, testing matters because like I was afraid of testing, just to speak the truth. When I first started at my first job, I was completely terrified of like tests. Nobody was doing tests to begin with. but everybody was talking about this, that this is a good thing to do, that should probably help us. But it was really scary to start to see good examples and all this. And I think that if I'm able to help people counter the same fear that I had, it would be already a huge achievement. And besides, I just want to grab all the experience I have from the years of testing, absolutely everything that you can think of, and I want to help people do the same. In case they're in the same situation, they can tap into my knowledge and then gain experience of their own.
You were afraid of testing. Why were you afraid of testing? Was it because it's something that people expected you to know and do, and you were like, I don't know yet, or was there imposter syndrome? I mean, I also was afraid of testing much earlier in my career. I can talk to you about that, but I'm curious if we maybe had the same reasons for being afraid of testing.
I think nobody quite had any like big expectations towards me, but I always had one toward myself, because I'm a self-taught engineer, and when I was given a chance to work and to be paid for writing code, I always took it seriously, and I wanted to, produce the best result I can. So I kept thinking that I need to do better, and that's probably where this fear came from, because I wasn't sure. Nobody taught me what is a test. I didn't see any examples, but I kind of felt that I need to start doing that, and I'm really happy that somewhere along the way that transition happened. And yeah, that had a tremendous impact on my engineering career and just life in general.
Wow. What led to that transition happening? Was it just that you took a look at a test suite and you saw English, you saw describe suite, it should something, expect this. Did you see the syntax and go, oh, that's it? Was that the moment where the fear broke, or was it something else?
It's so hard to pinpoint. It feels like an extension of yourself when you've been doing this for so long. I can't imagine it any other way. But yeah, I think eventually I came to interact with some tests, probably somewhere on GitHub. And I remember most likely it was like Mocha and all this library back in the day. And I think maybe something clicked. Maybe I just gave it a try. This is the way I learn anything. I just throw myself into this and I try to understand it by example. I try to just write whatever another person wrote. I see if it works. I try to change it. I try to break it. And I guess it just started from there.
Awesome. How long ago was that? You mentioned Mocha. Mocha hasn't been, the word Mocha in the context of testing hasn't been said in years. So this is probably some time ago.
I guess it depends. I think a few companies, and maybe quite a few, are still using Mocha. It's a great tool. But I think for me, it started at around like 2016.
Okay.
And I do believe Jest was already a thing. So my transition from like Mocha to Jest was very fast. And yeah.
Okay, so coming back to this mission of making the world, what was it? The world excited about automated testing, or familiar
just teach the world everything I know. Yeah.
Okay, and the hope then is that people make more reliable software that works as expected.
Yeah, of course, because like we interact with the software, especially if we talk about web technologies. It's everywhere. Web is on the phone. It's on your tablets. It's often on some terminals, whatever, in the mall. And I think if it's possible to help people write better software, more quality software through testing, this is a really good goal to pursue. So I would love to be able to contribute to that. That's
awesome. And you're contributing to that through Epic Web, as you mentioned with Kent C. Dodds. You mentioned you recently joined Epic Web. Is that in some type of employment capacity? Are you an employee of Epic Web? I didn't know Epic Web does employees.
It's more of a platform where I can take all my knowledge and just have an outlet to share it. So if I wanted to write about some concept for like years, finally I'm able to do it. I'm able to get this into as many people's, laptops and phones as possible. So it's basically providing me reach and I'm providing my experience, and we can coexist like this.
That is so cool. I can totally see how Epic Web is sort of this rocket ship that takes your knowledge and expertise to everybody. So with Epic Web, what are you doing specifically? Is it workshops? I know Kent does a number of workshops under the Epic platform. Are you doing testing workshops? If yes, I wonder if you can talk a little bit about those workshops.
Yes. So the whole Epic Web is based around the workshops. And this includes in-person, live, and on-site workshops, but also self-paced workshops, which is a really nice concept when you can just purchase it and go on your own pace. And it's the entire material with with the instructor pre-recorded and talking you through the videos with the problems and solutions. And that's exactly what I'm doing. I'm wrapping up my very first workshop on the fundamentals of testing. I just had a live session teaching that to an audience of people last Monday, I believe. It went fantastic. I got a ton of feedback. People loved it. We discovered some issues in my workshop in Node.js. It was amazing. And now I'm switching to this recording phase. So I'm able to put this into a video and everybody can go through these fundamentals on their own.
That is so cool. About testing, we're familiar, I think everybody listening either is or ought to be familiar with the idea that the ideal outcome, the fundamental outcome of testing is software that does not break when you change its source code. So I think a classic example of this is unit testing, where you have a function that returns a certain value given a specific input. And in a test, you can assert that for this given input, the function always returns this output. And you sort of lock in the function's behavior with the test. So 10 years from now, if you go in and change some internal details of the function, some implementation details, then your test will assert, okay, cool, nothing broke because for the same input, you get the same output. That's the fundamental outcome. You mentioned you touch on a lot of the fundamentals in this workshop. What are some testing fundamentals that you talk through to achieve those outcomes?
Apart from this, what you mentioned, having this like overall goal, I think I try to the first thing, I try to put the right mental model into like developers' mind. And we start the very first exercise on the workshop. We start with this kind of mental exercise on principles. Like what is the like ultimate purpose of testing? And I wrote an article about this on Epic Web already, so anybody can check it out. It's called The True Purpose of Testing. And I'm really trying to, I'm not going to spoil it here just to keep an excitement, but there's just one thing, very similar to what you said, but I put it slightly differently. And we're trying to get through this mental model in the exercise to understand why we write tests, what we expect from the tests, and even what contributes to a good test.
Interesting. Can you share what contributes to a good test?
There's a number of factors, but like I focus on one thing, which is the intention behind the system or behind the code. So because I see testing as our way to describe the intention. Just as you said, we wrote some logic. We want to make sure it keeps working. That's true. But what we also want to make sure that we have somewhere also written down what we intended this code to do, this logic to do. Because software is kind of a living organism. It changes through time. There can be a bunch of people working on the same thing. And it's really crucial to depict that intention in time using tests. And then you can rerun those tests and you can know whether your implementation actually meets the intention. So that's like an incredibly important principle to nail and understand. Yeah.
That's so cool. Yeah, I heard someone say, not even someone, like many people say that the true hallmark of really great tests is such that if somebody comes to your project and doesn't know where to get started, they open up the test suites and they read a test suite and they go like, okay, cool, I get the source code, and they can just jump in and start contributing because the test suite identifies the key behaviors of the project. Is that accurate? What would you say to that?
Yeah, I think it is accurate. Like ideally, your tests are basically a developer-oriented documentation on the features, on the product. I wish this was more common. I wish I could say, yes, this was the case in my every job or like in every project I've seen. But what's the point if everything would be perfect? We need to get there. So.
Yeah, what are some reasons why that's not the case? You sound like someone who's worked in a number of jobs where for some reason tests aren't this beautiful documentation where you can see a test suite and understand how to contribute to a code base. What are some of the reasons? If I was to guess, I would say priorities. We need to ship. The stakeholders, the investors are like, where's my product? And the CEOs and the decision makers are like, where's my product? Everybody's asking, where's my product? The engineers want to write tests, but everybody's like, dude, our users, our customers don't give they don't care about your tests. Is that, I assume that's one of the reasons. I'm curious if there are more.
It's definitely one of the reasons. Apart from this, I think just like me, a lot of people just fear the concept of testing, or maybe they're unsure. Maybe they don't know how to approach the code because there's so much different code, especially when we're writing modern like JavaScript, basically web stuff. We have a lot of frameworks. Testing may even differ a little bit. across the framework. So you kind of need to have a very good understanding of testing. And that's okay if you don't. I'm basically here to like help everybody get this understanding. And then, of course, there's priority, there's the cost. Not everybody will be on the same page in the team to even consider different testing practices. And this can also put the testing effort down. So there's a lot of factors. And then you need to be comfortable enough with testing so it doesn't eat a lot of your, sprint time or your effort in general. And so a lot of people see it as a chore, but I think you can make it into a very useful kind of reflex if you exercise it enough and if you're proficient enough.
That's so cool. I'm gonna get some free consulting from you since this is a podcast, and
go ahead.
And we're on here. If you want to invoice me after, that's totally fine. But I want to share with you reasons where I have passed on writing tests. These aren't business reasons. These are not like ship my product immediately. This is more me as a developer being lazy, frankly. And the biggest reason I sometimes skip writing tests is because I see the time requirement for writing tests, and sometimes I don't want to spend that time. I want to actually get something working. What led me to, and I'm sure you and a number of listeners can relate, what led me to really loving JavaScript initially was I could just open a browser, or I could just save a .js file with window.alert something, and I get this immediate feedback. Ridiculous. And as a developer, I've grown to love that immediate feedback. So if you tell me, hey, there's something standing in between you and your product that you can play with, and that is tests, I'm like, what? And so for me, I will confess, and hopefully we can fix it in this episode, maybe, that I don't write tests all the time. I don't go for tests first. I don't do TDD unless I'm creating a function, like a pure function that the logic needs to not break over time. So I do TDD. I do write automatic unit tests, but in very specific cases where I have a function that's doing like very intense, or not even intense, but is doing computation that I want to work predictably every single time. So I will unit test those utilities. But if you're telling me to like build a calculator app, and if we're talking about automated testing, then also write like Playwright or Cypress tests for your buttons such that they exist, and when you tap them, I'm just going to go like no. So I'm curious if you could speak to all of that. Is that how far off am I? How wrong am I with this approach?
You're certainly not wrong. Just that's actually the same thing for me. Just when you describe that you like this immediate feedback, seeing things working either like on the page or maybe in Node.js, that's the same thing I like too. I think a lot of other people like. But what happens with tests, they're not really keeping you away from this feeling. They're helping you automate this feeling. So instead of checking this file in a browser, I'm writing a test, and I can go to this particular setup at any point in time. This is basically a superpower you can learn, because for me, I really see tests just like use cases. So I have a bunch of use cases. I was working on some open source projects today. There's a ton of use cases, but I can kind of isolate and cherry pick whichever I want, and they're always there, running predictably. And it's kind of a tapping into another universe where I don't have to set it all up. And that's a huge value proposition of tests. Even if you like close your eyes to immediate value, like having your software actually working, for me, testing is the way for you to reproduce stuff.
Okay, I see that in the case of unit testing.
Yeah.
But how does that play into like, user interface testing or integration / end-to-end testing? Would you say that's similar, where if I ask you to build me like a clone of a social media application, how would you approach that?
I think it's absolutely the same. In fact,
wow.
the higher you go with the testing kind of levels, the more expensive it is to try one particular thing. Just what if you want to try how your social media clone app, handles like a new message, when you're posting it with a photo and maybe some hashtag. You need to go through so many manual steps just to get there. And being a human, you can really make errors on every possible step. So that's the point of the test. You automate this context, this environment, and then you can tap into this behavior at any point of time. So definitely, I would even, if I were to build this clone, I would even start from a few end-to-end tests. Of course, like I would not know like the exact layout and functionality, but once I do, and we can touch on that, like in which order you can approach testing. But once I have something written, I would definitely want to have like critical paths outlined with tools like Playwright. So if something happens or I'm just curious, I can tap into this test and basically stop it at any point of time and see what's going on. So no, I don't think it's kind of the gateway. It's actually a tool that requires learning. That's the cost, but it does give you a lot of power.
I must say, this is such an awesome take on end-to-end testing, because everything I've ever heard in my entire career so far is it's expensive, it costs a lot of time. Maybe leave it off until a product is more like fleshed out, until it's actually got some users. And then, so I've seen the reverse of this, where we actually completely leave off end-to-end tests until the product is well into production, and until users are using it, and until users have issues. And so I've literally seen this happen. A user complains, hey, I clicked this button and nothing happened. And then the engineers will go and investigate, find a bug, fix it. And then part of the PR, the pull request that fixes this is, okay, now add an end-to-end test for that case that the user had. So you can recreate their environment, as you mentioned, and make sure this never happens again. So it's reactive instead of proactive. And what you're mentioning here is, no, I would just start with that, because then you can carefully control the use case. I absolutely love that. And I think also, if more of us do it your way, that is not just proactively, but preemptively, what we can do, especially for those of us who are not designers, is we could just make the ugliest UI, but create the right buttons on the screen that are above the fold, that are positioned in the right way, and then hand off. And we can assert that the behavior works, and then hand off the rest to the designers, going like, look, this stuff has to be here for this accessibility reason, or that marketing reason, or whatever it may be. So I see a lot of value in that. You mentioned we could touch on the order of things. I also just now mentioned the order of things. Am I close to what you'd consider ideal there, or how would you approach that?
It's hard to talk about the ideals. I think no one advice will solve every team's problems, because every team is different. I'm not going to tell you, yes, start with end-to-end tests. Maybe you don't have to. Maybe depending on your product, you won't get much value out of this. Or maybe you just don't have enough engineers to actually sustain this test. You'd even write one test. And that's okay. Nothing's wrong with that, because these situations are all over the place. What's important is to know the tools, have the mindset. But touching on the level of testing, definitely, like when you start things, I'm not a big proponent of TDD. I think it can be a good practice, but for me and for many other people that I've seen...
Sorry to interrupt you here. Can we quickly, for the listeners, explain TDD a little bit?
Of course. Yeah. So TDD stands for Test-Driven Development, and is a development practice that encourages writing tests first and then covering this intention with the implementation. So then writing the functionality. So if you have a button that displays a pop-up, you write a test. When there is no buttons at all yet, it will fail because nothing is there. And then you slowly, gradually implement the thing. And if you have, for example, multiple criteria, you will see them passing one by one. This is a very primitive explanation. And why I think it rarely works in practice, because it requires one fundamental thing to work. You need to know what you're doing. And to me, well, I definitely don't know what I'm doing most of the time. I'm hacking different stuff on different levels, and it's okay. And to be honest, most of the other people also don't know. Sometimes requirements are confusing. Sometimes things change. Sometimes it's a different code base you were introduced yesterday, and it's fine. What's important is once you get the idea, so how I approach it, I do it kind of, I build a prototype. I ensure that it covers some minimum viable functionality. And
is the prototype, sorry to interrupt, is the prototype tested from the beginning? So do you write the test for the prototype? Okay, so you just make the actual application.
Yeah,
okay.
Not at all. I write the implementation to the very minimum that I need. I make sure that it's checked, that it's actually working how I think it should. Then I try to refine it. Maybe I see some potential problems already. And then when I'm happy with this kind of logic or the contract, depending on what I'm building, then I translate it into the test. Then I say, yes, this is working how I want it to work. Now let's verify it with tests and basically cement it in time. I think this works for a lot of people I've seen, and even a lot of products, especially when you're like in startup environments. You move fast, you want to build a feature. Not everybody is very keen with starting with extensive, end-to-end tests. Not very, presentable, useful to the user. But once you have minimal functionality, it's a really crucial step to cover it in test.
So it freezes the fact that it works in time.
Yeah.
Would you say that every pull request should ideally every team's different and so on, they have different ways, of course, but if you were like the founder CEO of your company and your company was a software company, would you, or even a CTO or something like this, would you say that it's a good practice for engineers to strive to have every PR be accompanied with some type of automatic test?
I think it's a little harsh of a rule, but what I would say, and I would really encourage people to follow, is that whenever you have a bug, I wouldn't consider a fix actually a fix unless you provide a test that confirms that. If there's no test already, but then again, if there was a test, we would have called the bug. So you see the thinking now. Yes, any bug fix must be accompanied with a test. If it's not, it's a workaround. Because things will change tomorrow. No way for you even to know that your fix is no longer relevant. So yes, this is perhaps one rule I would make.
So we include a fix, and the way to prove the fix actually works is to add a test. And also, yes, go ahead.
Actually, I like to approach it from the other direction. To prove that you have a problem, you add a test that fails.
Yeah.
And you commit it. And then when you have this reproducible situation, not only you can fix this, maybe you have a vacation tomorrow. Anybody can jump on that branch, run this test, and see if their solution is getting them anywhere. So yeah, start with a bug with a test to prove the bug, and then write a solution that has the test passing.
That is so cool. If you're ever like running a software team, I would love to be on that team, because I think the software you'd create would just be robust AF. Anyway, thank you for talking about all of these things. We did start with Epic Web and the workshop, and as you mentioned, the workshop will touch on all these things. I also heard from you sort of before the show that you've got other exciting things planned for Epic Web and these workshops. Is that something you wanted to elaborate on here?
Absolutely. Like, as I mentioned, my first workshop, I'm already switching to the recording phase, so I hope people will get their hands on it hopefully this month, depending on when this recording comes out. So maybe it's already out. Go check epicweb.dev to see. And I am already working with the other topics on testing, the other workshops, because not only we want to revamp testingjavascript.com, we also want to bring more value and elaborate on a lot of topics. So what KenCDots did with that resource is phenomenal. It gives a very solid foundation to everybody who wants to get familiar or improve in automated testing. What I want to do is build on top of that foundation, bring a bunch of modern tooling, because some things have changed since then. And I also want to kind of push all those topics a little farther. So even with the fundamentals, we push them a little farther. Even with things like mocking techniques, we're going to have a comprehensive dive into what are different mocking techniques, when to use them. And that's the whole goal. So I'm really excited to join this effort. I will do my best to fulfill everybody's expectations, basically, and most importantly, just get a lot of value to people so they can start writing better tests.
Yeah, just from talking to you here, I feel motivated to make testing more of a prominent part of my software development flow.
That's awesome.
Yeah, absolutely. You did mention mocking just now, and I have to assume you're talking about like not making fun of people. I'm just joking. No, but could we for the listeners define mocking and then talk about some really awesome mocking strategies that we can use in tests? I want to go ahead of you and say that I absolutely love mocking, and I just want to shout out my favorite library for this is Nock. It's a great tool for HTTP mocking in the Node.js world, and I just love that the name is Nock, like Nock, and then they say when you call an endpoint, you knock on it, like you knock on the door. I think it's all just so cool the way they talk about this library. Anyway, sorry. Aside, can you explain mocking for us and maybe outline a few mocking strategies that you're excited to teach in Epic Web?
Yeah. So mocking in itself is just a technique, and it helps you to establish testing boundaries. In other words, it helps your test know where your tested system ends. Because when you test real-world software, you basically have this kind of a tree of logic. And what you want to test a particular branch. But sometimes you cannot just snap that branch and put it in a test. It would lose its value. What you want to do, you want to have the whole tree, but mock replace some of the branches. So they're kind of there. They don't get in the way, but you can focus on a particular behavior where it leads you. This is kind of a basic explanation I would give to mocking. And there are a lot of techniques to achieve this. And what I'm trying to do, how I approach this in the workshop, I'm trying to focus on particular things. So what if I want to mock an object? Well, here's how you do it. What if I want to mock a global? And we're approaching this in TypeScript as well. So you would have most often two parts to any mocking. You want to mock the runtime values. You also want to mock the types. So if you're mocking some global variable, you want to make sure TypeScript knows about it and you're actually getting the valid code. And then if you want to mock promises, there's a different approach. Touching on the network, you may use libraries like Knock. So there's a lot of different approaches, and I find it to be it's great to structure them based on what you want to mock, instead of like approaching different techniques in isolation.
Yeah. What about this? I've only ever had and this is probably invalid, but to my best recollection, I can't say only ever, but I would say most commonly when it comes to mocking and tests, I've had to mock mostly IO, so input output type stuff. Mm-hmm. Meaning if I've got a Node.js function and I'm reading from the file system, then I will mock FS. I will replace FS, that branch, as you mentioned. That's a beautiful illustration, by the way. I'm tempted to ask how long you've practiced that, but that's a really excellent analogy with the tree and branches. So if I'm writing to the file system and it's an automatic test, I obviously don't want to create a bunch of nonsense on my file system. So I would mock FS or file system in Node and replace it with some object that, has like read file and it's just a function that does nothing, or a function that maybe returns me something, whatever. You get the idea. Yeah. This is I'd say 90+% of the time I've had to reach for mocking. But you just mentioned mocking objects, globals, etc. I'm curious if you could speak to like non-IO types of mocking and when they're applicable and useful.
Yeah. So what you mentioned with, for example, accessing the file system, it's basically a side effect that your code has.
Yeah.
And you don't want it to happen, right? You don't want to write to the system for one reason or another. Maybe you want to mock a situation when you write to the system and it gives you a specific error. So that's one way to use mocking to establish these boundaries. But you can spot that I'm heading in a particular direction. So even though mocks establish these boundaries, what they allow you to do in practice, they allow you to model different scenarios. And mocking some side effects is one way to model them, because very often people mock things that they don't own. For example, the network. That's a really good idea to mock third-party services, especially because you don't know how they're going to work. You don't want to make them affect your test. But there's also other things. Maybe you have a complex class or a function, and you want to put it in a particular state. Sometimes they may depend on other things, directly or indirectly, and you can use mocks to kind of put them in the right state. Maybe your function has, I don't know, some sort of controller, and it's a different class, and you want it to be pre-configured. Maybe it's the controller who does the file system calls, and now you can mock it on the control level by introducing this like dummy controller. So that's the point. You definitely use mocks to handle side effects, but you can use mocks and dummies to basically emulate any scenario you want.
Interesting. So mocking, instead of just like replacing side effects, it's the broader definition of mocking, the broader use case of mocking is, you would say, to help with, and pardon the poetic language, but would help with world building. You literally create like the world, the context you want to execute your tests in. And not just execute your tests in, but to isolate the one specific behavior you're testing. You orchestrate the entire surrounding through mocks. You put everything in a certain condition such that the one thing you're testing is allowed to be tested in the truest form. Is that accurate?
Yeah, that's pretty much it. That's why mocking often happens on the setup phase, and that's also why I think like testing setup phase is the most important phase, where people underappreciate it, and it always can use more love. And that's where mocking lives as well. But you have to be careful, though. Like you mentioned that you kind of introduced these mocks to emulate behaviors. You do need to make sure that you're not mocking what you actually want to test, obviously.
Yeah.
But you always want to try, when you approach mocks, try to make sure that even if you mock things, you still let your system, your tested code, maintain some integrity. So maybe like mocking too much, for example, would basically grab your code and put it in a separate universe where it never runs in practice. That's one of the reasons I build a few tools around this as well, to help you basically execute as much of production, quote unquote, codes as possible, while still giving you control over these boundaries and over different use cases.
That's such a good point you raised, because depending on what you're testing, you're going to want to mock differently. What I mean by that is if you're testing like a utility pure function, a unit, then you would, and say that thing relies on some input from the network, you would probably mock the network because you want to control the conditions in which the function operates. However, if you're testing the same function as part of an integration test, then by definition, you cannot mock the network. So knowing the boundary of when to mock, what to mock, how much to mock, I think is a whole topic unto itself, is an art unto itself. What would you say to developers struggling to find the right balance?
I would say definitely make sure that what you're testing is there and it runs in the same form it runs in production. When this is true, you can rarely go wrong with mocks. And the next thing I would say is that just remember this is a tool. You can cut your branch, your tree at one level and achieve one particular kind of test, maybe focusing on a different thing while testing the same code. And then maybe you can push your mock forward and now it focuses on another thing. Yeah, right. Like you mentioned, the code that interacts, for example, let's say the code interacts with your server and your server then interacts with third-party server. So depending on where you introduce the network mock in this case, you will be testing different stuff. I can make the cut between my client, my code and my own server. And now I'm just focusing this test on the client and I'm treating my server as a given. It's mocked, so I have full control over it. And in another test, I can push this boundary to the third-party provider. Yeah. Now suddenly I'm also testing how my code interacts with my server, but I'm taking the third party out of the equation. So you see, like you kind of move this wherever you want and you achieve different thing. So that's basically it.
To be really, this is probably disrespectful what I'm about to say, but to be really hand wavy, to be really oversimplistic about things, if a developer shows up and asks you, hey, I'm new to mocking, I'm trying to get a feel for how to cut my tree properly. As a rule of thumb, would you say it's better to bias towards over mocking or under mocking in trying to find the right level of mocking?
Definitely under mocking would be better, in my opinion. Because by definition, when you mock, you do take away from your tree, from your system. And you don't want to take away too much so nothing is left. So definitely, the less mocks your code has, your test has, in order to run, the better. It's just sometimes you really need to mock things in order to have the proper focus. And I have a really good rule about this. It's not really about mocking. There's a particular rule that I've been following for years, and I finally had a chance to write about it in Epic Web. So it's called the golden rule of assertion, and it's a very simple rule. It goes like this. Your test must only fail if and only if the intention behind the system is not met. And I can give you an example because it's a sentence. Who knows what it means? The example, let's say you have a code that interacts with a third-party server. Yeah, we probably know we should mock it, but let's focus why. Let's focus on why. Because imagine if you are expecting the server to send you, I don't know, a user object. And it does, right? It's a function and server. It's cool. Your test is passing. Now imagine that server gets a new deployment, or it's in this weird limbo phase where it's being deployed. Maybe it's not evaluable. Suddenly your test fails. Mm-hmm. Now, any test failure should indicate the problem with your implementation. But what if your code handles the user object correctly? There is no bug. It just so happens the input right now, the side effect, is not being fulfilled. Well, in this case, it's an indication that something is wrong with your test, not the code. Because your code is functional, your test is failing. In this case, because of a side effect, in the form of a server. Here's this golden rule of assertion comes into place. And it really helps you uncover a lot of problems, not just mocking, but mocking is like a particular solution in this case. So yeah, definitely under mock. And if you can, not mock at all, of course.
That's so cool. Okay, so mocking is just a last resort to help you create the world you want to create so your tests can run in their truest form. Fantastic. While we're on the subject of mocking, you created a mocking project. It's called Mock ServiceWorker, MSW.
Oh, yes.
I wonder if you could spend a few minutes talking about its creation and then its iterative process, because it is open source, and I assume that there was a lot of community input.
So Mock ServiceWorker, or MSW, it's an API mocking library. So it helps you achieve what we just discussed previously. It helps you mock network communication And yeah, let's talk about how it was created. So it was a prototype that I built. I was dealing with tests. I was already writing tests, and I believe I was using JSON server to run my test against a different endpoint, basically my local JSON server, mock server. And I wasn't quite happy with how I had to change a lot of things in order to route my traffic to that server, because effectively you need to change your implementation. So suddenly, instead of api.prod.com, you're fetching localhost at 3001. And that's a red flag for me. And it feels like I'm hacking my way into the right behavior in the test instead of actually using mocking as a tool. And yeah, I don't know. I was just unhappy, and I sat down, and as I always do, absolutely love this practice. I grab a piece of, like a sheet of paper, and I write down the perfect behavior of what I'm trying to achieve. So it's API mocking. What would a perfect API mocking look to me? So here we go. There's 5 items. And then I tried to see, how do I implement this? Is it possible? Maybe it's not. So I started researching, and eventually something called ServiceWorker API popped up. It was already established API in web standards, and it's an incredible API. So it basically allows you to intercept requests on the network level in the browser. So it's a separate thread that runs in the browser next to your main JavaScript thread, and it intercepts requests by default. This is done by the browser, and it can signal you back whenever a request happens. And it was primarily built for caching purposes. So a lot of, I believe it was on the foundation of PVAs, of progressive web apps. You had the worker that was able to intercept requests to styles.css, and instead of going fetching that, it could just look up it from the browser cache and give you this kind of instantaneous experience of a native app, because you can cache a lot of things, and you can even have like offline functionality also enabled by service workers. So that looked really cool. Intercepting the network on the browser for free. Sign me in, sign me up. And I started hacking at it, and I wrote initial prototype in 2 days, which was 100 lines of extremely ugly code that nobody will ever see because it's private. And yeah, it was there. Then it sat there for a while, as most of my open source projects do. And then probably one day I got particularly inspired by this topic, and I went to that project. I picked it up, I tried to clean it up, and put it under a different name. So now it was called MSW publicly. And then nothing happened for like months, I don't know, probably months. And what happened then is I just got a lot of notifications on Twitter for some reason, and I couldn't figure out what was going on. And it turned out that somebody has mentioned my little repo. And it was actually not just somebody, it was my colleague, my ex-colleague at the time. So he knew about this project because I was very vocal, expressing all the awesome things I built. I came to work like, hey, I built an event like accumulating logic, and I didn't know a lot of stuff. So I reinvented a lot of wheels, and I left those wheels to gather dust, but I learned a lot on making wheels. So, and then I was also sharing my excitement about the service worker stuff. And apparently one of my colleagues liked that, and he mentioned it to Kent Dots. I don't know if I knew Kent back then. I probably didn't. And Kent was building his Epic React, I believe. I believe he was building Epic React, and he had to control the network as a part of his course. But he wasn't happy with the other solutions, because what they did, they kind of took your fetch function, for example, and they replaced it with another fetch function, like a mock fetch function. And what ended up happening, well, obviously when you fire a request never happens. We just pretend it does. And he wasn't happy about this because it was hard to explain. Requests were kind of getting thrown into the air, and they weren't visible in the network, which was a huge factor for him. He wanted his students to understand the network, to see the requests. So he looked at this mock service worker thing, and it was a complete mess of a project, let's be honest. Like it was barely working. It was a prototype, and he seemed to like it. He started opening issues like, hey, maybe it could do this. How about doing that? And I remember that thrill when I saw this notification thread and I ran to GitHub and I started cleaning up aggressively, like nobody should see this. And yeah, the rest is history. It took us like half a year or something to get it into a good state. And then it was a browser-only tool. So obviously, ServiceWorker API is a browser API. And then what if we want to mock stuff in Node.js? What if we want to mock it on, integration level? So then I added support for Node.js, and suddenly we achieved this thing that can have a single network contract and run anywhere. That's the story.
Wow. There's so much in there, but before we get into diving deep here, I just want to applaud you for scratching your own itch. And that itch itself is such a purist itch. I hope you don't mind me saying that. I don't mean it offensively at all, but it's so purist because I feel like the vast majority of us, myself included, would, if we're doing a test and our implementation has like fetch to a certain endpoint, would my initial mindset is I'll just use an environment variable. So if process.env is test, then fetch from localhost something something. If process.env is production or is local, then sorry, not local, is production or like staging in the cloud, then fetch to a different service. Like I feel like that's the definition of environment variable was for. But you're like, no, I'm not going to change anything in my implementation. That is so purist. And I love that that's where MSW came from. You're like, no, there has to be a way. I think that's so cool. Then you mentioned Kent had the same issue and so on and so forth. How did you end up adding support for Node.js? That is so interesting to me because, as we know, service workers are in browser specifically. Node.js, as far as I know, at this point in time, does not have support for service worker. I don't even know how that would work. So if you could speak to that, I'd be so interested.
Yeah, it was definitely a challenge. The API is not there. I don't think Node.js even needs service workers, but yeah, there's no same API, so we couldn't just import it in Node. It would throw. So we had to build some sort of interception logic. But thankfully, even back then, I spent enough time in open source and authored a few projects. So it gave me an idea of what is a good API design, as much as I could know back in the day. But I'm very, very happy that I did a few fundamental decisions in MSW that still stand until today, that help me ship every feature. And I know that it's going to be a good feature because I'm still true to these principles. So one of those principles was to be environment agnostic. So I wanted to have a declarative API mocking where you, the developer, you focus on the contract, you describe how you want the network to behave. Everything else is the problem of MSW. You shouldn't care about this. It was a really good abstraction of like request handlers. There's basically functions very similar to like express route handlers, if you're familiar, or like Festify. And we took the same network description. We just have to have a different source of requests now. Instead of the service workers sending us request events, we have to come up with something in Node.js. So what I did, I take a look around the ecosystem. I know Nock is an amazing project. I love Nock. It was around for a long, long time. It's probably like 14 years old right now. And I take a look at Nock and I dove deeper to see how they basically provision the interception, how they do it. So I noted it down. Yeah, okay, they patched the HTTP module, http.cat, replacing client requests. It's very fun stuff. I had no idea about like internals of Node.js back then, those times. And then I went around and looked at other solutions as well. What are they doing? Maybe I can learn from them. And I ended up writing a library called Interceptors. And it was basically a low-level interception library that I didn't even want to couple with MSW. Anybody can grab Interceptors library and build their own API mocking solution for Node.js. And it's at the first iteration, it tapped into the client requests. So we were basically intercepting the http.get and http.request calls. Most of the folk don't use those directly, hopefully. And third-party libraries do, however, because that's the way to make requests to Node.js. It used to be back in the day. There was no fetch support. People were doing the client requests. And we were able to spy on them and kind of hijack them in proper places, then properly write the mock response. It just forced me to learn how the whole network works in Node.js. And I'm still learning, bits and pieces here every day. And then we released this Node support. to be honest, like I already went through probably like 6 iterations on that like protocol of interception, and I'm writing the 7th right now as we speak. Today I had an idea on the weekend. I won't spoil why, but if I can pull this off, it would be a really, really good change, not just for MSW, for a lot of other things too. So yeah, it's definitely one of my favorite projects technology-wise. It's the right mix of hacky, challenging, and educative, because I don't want to replace stuff. I want to tap into the internals. I want to write that socket. I want to have the actual network behavior just give you the control only in the right moment. Yeah, that's Node.js support.
That's so interesting. I feel like if I wanted to do something like that in Node.js, I would sort of follow a similar approach. I wouldn't think to go and read the source code of Knock. I think that's really great. And that's, I think, a takeaway for anybody wanting to implement similar things is go look at the source code of other projects. And I feel like a deterrent to this is some people think, oh, but it's so scary. I don't think that's entirely true. For example, the source code for React, yes, it is scary, but it's scary by design, right? So that React does all this heavy lifting, so you don't have to. So like it's scary because it's extremely declarative, but not all things are like that. For example, the source code for Apollo Client or Lodash or Knock, as you mentioned, is somewhat readable, and if it's not, to some developers, there's now AI tools that will explain it to you and so on. That's a fun rabbit hole to go down. But I think that is one takeaway. Like if somebody wants to implement something like this, the source code of an existing project. What I would have done is not that though, because on some look, I've been writing code now for 23 years. Amazing. I've been an open source for 10 of those. I'm familiar with reading source code, but somewhere deep inside me, I'm still somewhat scared of like projects. So I wouldn't think to go to Knock. What I would do is inside a fetch request in Node.js, I would just throw or do console.stack and literally look at the stack from there. Like, okay, what is fetch relying on? Let's go deeper to at some point end up exactly where you are, the HTTP module, which everything uses. I think now in the newer versions of Node, there's a library called Undici that's in use there. So I would then go look at Undici and so on. But I think that's definitely rife with practical takeaways for people. Since you're mocking the network, I have to assume that it's not just HTTP, but it's also WebSockets, which is a whole different beast, right? And there's also secure layer for both HTTP and WebSockets that I don't even know how those would work locally to mock them. If you provision your own certificates and so on, yes, you can. Are there differences at the network layer with secure versus not secure? And then if we could talk a little bit about mocking WebSocket communications with MSW, both in Node.js and the browser, that would be very interesting.
Yeah, so regarding the secure and insecure layers, one great way for us to bet on the technologies like ServiceWorkers is that we don't really have to care about that. So you have your network description, and if you describe an HTTP request or HTTPS request, it doesn't matter. Both will be intercepted by the worker, and you will get them back in your handlers, and you'll be able to describe how this request should behave. This was really nice. In Node, it's very similar just in the sense that we basically tap in a different module, because there is an HTTPS module for secure requests that then uses different connection. And that's basically how we do it. So you as a developer, you don't really care. You have all the tools you want. And us as the library, we just know where's the right place to get those requests from. And regarding different protocols, that's actually not yet the case right now, which from experience is enough for a lot of people. But of course, there are different applications and different kinds of products you're building. And we are experimenting, working on a WebSocket support, which is actually in a very good place right now. So I'm done with the interceptor part because maybe spoiler to some, but WebSocket class is coming to Node.js, which is amazing. And it's one of the factors why I was able to finally implement WebSocket interceptor. Like in the browser, it wasn't that big of a problem. But in Node.js, when I sat down to write WebSocket interceptor like 2 years ago, it was a complete mess because there's no standard API. So libraries do it in whichever way they want. And for us, the common ground was the socket layer. And it wasn't high enough to have the context that you need to mock effectively. But now that's no longer the case. So I have the implementation there already merged actually publicly, but not for MSW users. So MSW will have its own API that's more developer friendly, where you have a familiar experiences with like overrides. And it took me some time to get to the right API shape to help people describe WebSocket networks. Because with MSW, you're describing the server side. So you're approaching all these handlers from the server perspective. But unlike HTTP, WebSocket is unique. It's a duplex communication. Client and server can receive events independently. So what ends up happening, MSW isn't really the server. It's kind of a middleware sitting in between client and the server. And there's a little mental shift that was really challenging. Even like I was completely like confused, but I finally figured out like where you should stand, because you can have like outgoing request from the client, incoming request from the actual server, and then you have MSW. And hopefully I was able to write about it in the docs that people will see how to like think about it, how to make sure you're, can describe what you want to describe with WebSockets.
How should people think about it? How can you describe what you want to describe with WebSockets?
So,
I was just gonna, because you mentioned this is in the docs, I wonder if you could break that down here, because I feel like now, even me just listening to you, I'm like, oh, what is that? And I feel like a lot of listeners are gonna have that.
I can absolutely break it down. So you think of MSW, as I mentioned, as a middleware.
Yes.
So something that sits in between, but there's a really cool switch that you can pull. So it ended up a little technical implementation details, if you would. So it ended up having us make a few choices in order to have this predictable network description. So the first choice is whenever you describe a WebSocket interaction, communication, your client, like outgoing client events, will be intercepted by MSW, but they will not go to the actual server by default. So in this case, by default, MSW acts as a server. So you can have your client, MSW, and they can talk to each other. So your client sends real events that your application makes. MSW, your event handler, responds to those events or broadcasts whatever it wants. So that's the default behavior. I think this is really crucial for people building mock first. And this is where you do need API mocking tools very often, because you don't have the server or you don't control the server. But then what if you want to bring the actual server into this whole story? So this is where you can pull this lever. We have a method where you can tell the handler to make the connection to the actual server. It's an explicit choice. Once you make the choice, your handler will have connection to the server, but your client sent events will still not go to that server. You have to forward them manually. The reason for that,
you have to forward them manually from the handler. So by handler, you mean MSW?
MSW, yeah. So your client will send events, MSW will receive them, but it will not forward them to the server. Yeah. Why? Because what if you want to change those events? Maybe you want to modify the data you're sending. Maybe instead of event A, you want to send to event B. So the forwarding is your explicit choice. It's not difficult to do. You just create a message listener, and whenever a client emits message, you do server.send with the data. So it's one line of code if you want to have like full one-to-one forwarding from client to the server. And then since you establish the connection, you can actually add message event on the real server too, and suddenly you're receiving the real events too. And here's another default we have to make. Now the events sent from the server will be sent and forwarded to the client automatically. It sounds unusual. The reason for that is that once you connect to the server, you kind of intend to get something from the server. What's the point to connect if you don't intend to communicate with it? So the client sent communication is explicit, but the server sent is implicit. And it's a kind of opposite story. You will receive all the events, they will come to your client, but you can intercept them. And here's the beautiful part. Since we're dealing with events, you can call event.prevent default. And since the default behavior is forwarding from server to the client, you can prevent all events or particular events from ever reaching the client and do whatever you want with that. Maybe you want to intercept an event, prevent it, and modify it, for example, and then send a modified version to the client. Maybe you want to intercept server event and send a different event to the client or do nothing. So those kind of defaults were kind of like a little tricky to make, But I think those are the good defaults. I will see what people say. I hope we will have a few release candidates and people will be able to share their opinion. But I think it makes sense. Once this clicks for you, I believe it's useful.
That's so cool. So what it is essentially just a proxy. Like ServiceWorker is basically just a proxy on the browser, and this is just a proxy of Node.js. But you've exposed some sort of developer experiences around how to interact with these messages based on where they originate. I'm going to say back to you what you just said, or rather what I understood, so that I understand it, and I'm sure the listeners also will understand it. So you have MSW, which is a handler. And when you connect from a client to a foreign WebSocket server, you actually don't. You connect to MSW, and then MSW connects to the server. And then you send events to MSW. MSW receives them, and when you receive these events, you can manually forward them to the server by doing like server.send. I think that's what you mentioned. Or since you receive the events at MSW, you can like do a big switch case on them, and based on the type of event and its payload, maybe you can do other stuff. You could intercept them and do literally whatever you want. You can transform them. You can not send some. You can send only specific types. And this really helps mocking, right? Because you just want to test one specific event that's sent.
Exactly.
So am I good so far?
Yeah, that's right.
Great. And then from the server side, this is interesting because MSW does connect to the server when the server sends you some. Okay. So you can choose not to connect to a foreign server as well. You could just have MSW be the point of termination. Yes. Okay. And then if you want MSW to connect to the server, you allow that. And when the server sends something back to the client, MSW does send that directly to the client. You don't have to manually do like client.send. Okay. But then how do you intercept a message coming from the server? Is it just like, is it the same as you intercept a message going from client to server, except there's no manual, like, I want to send this now step?
This is absolutely the same because both parts are based on event target. So one important thing to mention is that with the recent changes that we did last year, we're trying to promote web standards as much as we can. So people who mock APIs with MSW actually learn about the web, about the platform they're using. So in terms of WebSockets, working with MSW will be exactly how you work with a WebSocket class, which implements the specification. Okay. So to listen to the server event, you just do server add event listener message. And basically there you get an event object. And by default, it will be sent to the client. There's definitely client.send, but it calls that implicitly. And if you want to prevent that, you need to call event.preventDefault, which prevents that.
Why is it not the same for client to server communication? Why is it not forwarded by default? And then if you want to not send it, you event.preventDefault?
This is a fantastic question. So why it's not enabled from client to server communication is because if you connect to a non-existing WebSocket server, a WebSocket constructor throws an error. It makes sense, right? It's the same as you connect to non-existent HTTP server. But I may be completely wrong on this. I would be happy to be proven wrong. But from my experience, this particular error that this WebSocket constructor throws is a bit unique. First, you cannot try catch it. I encourage anybody to try. Go to your browser console, write new WebSocket, and then give it a WS whatever garbage URL. Try to wrapping it in try catch, and try to actually catch that connection error. You won't be able to. It's the same in every browser I tried. Yeah, and for that reason, we have to be a bit precautious with MSW because, as I mentioned, you introduce mocks for things you don't own, but also for things that don't exist yet. So what if I develop my app and I want to have a really cool real-time app? I'm just not a backend engineer. Or maybe I'm lazy, I don't want to do servers today. If you try to connect to that particular endpoint, it's going to throw. Nothing we can do about it. And that's why we introduced the default that MSW will act as that server until you explicitly call server.connect. And under the hood, in this connect method, we will actually construct the WebSocket connection. And you will get the same error, for example, if this connection doesn't exist, which makes sense. But until you do make that choice, your actual server is MSW. And the other reason is, if you develop mock first, if we do the forwarding to the server by default, you would have to opt out from it. And I'm trying to design APIs where you opt into behaviors as much as I can. So it's kind of you stack the expectation instead of like making an exception.
Yeah, that makes so much sense, and it makes sense that when a message comes the other direction, so from a server to a client, that is not intercepted and explicitly forwarded because you can't mock the client. You're testing the client.
Exactly. Actually,
okay, yeah.
Yeah, you can mock client events, but you can't mock the client. Yeah.
Good. Wow. I feel wealthier in knowledge and information. Thank you so much for that. So open source is hard, and MSW is open source. I say it's hard because it's not sustainable unless companies give you money. Like there's no way to. I think there's a lot of people who are familiar with the pain of open source. For example, you get issues, you feel an enormous amount of pressure to solve them because, oh my gosh, this is my community. People depend on my software. I'm not sleeping. I'm not exercising. My whole life has gone dysregulated. What do I do? I'm sure I'm maybe touching on a nerve here, but I'm curious, given that position of open source and sustainability, how's it going with MSW? And how can developers, so in terms of code issues, pull requests, or companies in terms of money, contribute to and benefit from supporting the project?
Yeah, so for years, and MSW is 6 years old, I believe. So for years, MSW wasn't anywhere near sustainable. It was a weekend hobby project. Even when companies like Microsoft and Google and Amazon picked it up and started using it, it was still a weekend project. And it was really hard to kind of pull it off and to give it proper love and attention, especially since, as you mentioned, a lot of people start using it, they start reporting issues, you start feeling like it's your responsibility to have this really good software available for everybody. It was hard. And it was hard like until last November or so. But then things changed. I was able to get into Codacy Pioneers program, which helped a lot with like financial sustainability. They sponsored the project. Then I was able to strike a great partnership with Chromatic. Chromatic were one of the first folks who picked up MSW and one of the first sponsors. And now we pushed it forward, which is amazing. It gives great future for MSW and it gives support to everybody writing stories so they're able to mock the network in a really nice way. And bit by bit, somehow, I actually paid my first rent last month from open source contributions, which is amazing. I'm extremely honored and humbled, and I will try to dedicate as much effort as I can. I'm really doing my best this year. I don't have a full-time job, and I'm kind of balancing open source and education. And I think the results do speak for themselves. We were able to solve two of the most requested things in MSW for years, which is concurrent run support in Node.js and also the WebSockets that we discussed. So I'm really excited to keep pushing this forward because I kept screaming about it all this years. I'm saying, imagine we changed the way people mock APIs while doing this like over a weekend. What we can do if I'm able to do it full time? What if two people are able to do it full time? And now I can have this little kind of proof that it's possible. Yeah.
That is so encouraging. Wow. I think there's a message in there for all open source maintainers that if your project, if you believe in it enough, and if you believe in the mission, as you mentioned, then it's only a matter of time until people see the value. That is so beautiful. You mentioned two issues that you're solving with Node.js. One being WebSockets, which we discussed in depth. The other one we didn't discuss yet. I'd like to discuss that. What did you concurrent? What was it?
Yeah, it was concurrent, like basically concurrent testing support.
How does that work? What are the challenges there?
So if you're familiar with like frameworks like Jest and Vitess, they allow you to run your tests concurrently. Yes. People sometimes confuse this with parallelism. It's a little different. So parallel tests is when you have multiple test suites that run at the same time, but each test suite is still isolated. Very often it's a separate worker thread in Node.js, so they don't know about each other. What concurrent test run does, it also runs every test in a test suite at the same time. And people utilize this pattern a lot to have better performance from the tests. This is not enabled by default because it requires really careful test orchestration. So you don't have any leaking data, any shared state. And people who use MSW in these situations, they were struggling with MSW because MSW introduced shared state. Like internally, we keep the list of all request handlers, and we allow you to modify that list. So if you can have a happy path test, which is awesome. Then you can have a test that checks how your logic behaves if your server sends an error. So to write this test, you go into the actual test closure and you use something like server.use and you append the override. So now suddenly these requests, they have these responses. They are different from my happy path responses. So these overrides, they mutated the list of the handlers. But since we kept that list outside of the test scope, unlike tools like Knock, we introduced a shared state. So suddenly, if you have two tests running at the same time, maybe your error test runs first, adds this override, affects the network, and now your happy path test runs, and suddenly it receives an error. That kind of sucks. And it's been there for a while. It wasn't a simple issue to solve. We were looking into any ways to identify, to have some ID. Can we maybe identify different closures in a single module so we know this is red and this is blue, and they shouldn't kind of affect the network of each other? And finally, we were able to solve it, I think last month, using a very interesting global API in Node.js, and it's called AsyncLocalStorage. So AsyncLocalStorage is basically forbidden magic wrapped in a public API. And it does a lot of things, probably a lot of things I don't understand. But the idea behind that, the whole API, is help you track resources in Node.js. Different resources like a socket has been constructed or HTTP message was sent or something else. And they attach different kind of execution IDs to those events. Wow. And for you as a consumer, you can wrap any function in AsyncLocalStorage, and you can run it with particular context. So it's very it's extremely hard to explain in words, but how it works is that if you imagine you have a test, if you put your test in this AsyncLocalStorage and you run it, anything down the line, anything you call in that test, even if not directly, can call like storage like something .get store. And it's able to get that storage that you passed to your test initially. It's kind of I don't know what to compare it to. I think like one comparison that came to my mind is when like I remember React team used to throw promises.
Yeah.
To be able to access data like down the line and then kind of communicate back. And AsyncLocalStorage is very similar in that regard. So what it allowed us to do, it allowed us to push this list of handlers. Instead of being a global state, we pushed it to each individual test closure. But what's important to know, it's an explicit choice. So I tried doing it implicitly. It's not a good idea. It's implicit choice. So you go to a concurrent test and you wrap it in server.boundary. And we call this API in MSW server boundary, which basically means this is the boundary of your network. So any modifications you make within that boundary will never leave the boundary. And it's honestly such an amazing concept when I'm talking about AsyncLocalStorage that you can have even nested closures communicating isolately from one another while still inheriting context. Mind-blowing, but really awesome that we can rely on Node.js to fix actual problems people have and like solve this concurrency. So now suddenly when you modify the network, it hits the boundary and bounces back with whichever handlers you have, and it doesn't affect other boundaries.
That's so interesting. I feel like this warrants a podcast episode on Contagious Code podcast about async local storage, and we need to get to the bottom of this, go deep and understand that entire API, because it does.
I knew, yeah.
It does sound somewhat magical, and maybe when the episode's out, I can send it to you and get your feedback, because that, yeah,
for sure.
What I'm hearing sounds like some Doctor Strange black magic that I'm very uncomfortable with, frankly, and I need to understand. Yeah. Okay, your journey with MSW is definitely a special one, right? You built this thing just to scratch your own itch, which was also, not many people's itch. It was just like, I don't want to use an environment variable. You built it. It took some time before Kent noticed, and it sort of went over the moon. From this journey, you've got, and you mentioned you were doing a lot of open source around the time as well. So you sound like someone who is extremely well versed with open source, but also building and maintaining an open source project used by a number of Fortune 500 companies you mentioned. I'm curious, what are some strategies for doing this well. And by doing this well, I mean, having healthy work-life balance and not feeling maybe the enormous maintainer pressure and getting to the point where you're able to actually pay rent from. Congratulations, by the way. Surely this wasn't an accident. There was a degree of intentionality. There was healthy ways of working. What are some of these healthy ways of working that you think is important for listeners to hear in case they have similar projects and struggles?
I will definitely say that for many people, when they build open source projects, naturally they imagine some state of success. So for some, success may be wide adoption of this tool. For some, success may be like sponsorships that can help you pay rent. For some, maybe success is like giving an internal talk on this tool in your company and having 2 people like it. That's precisely my experience. I did a lot of stuff like this just to share. And whatever is your goal, whatever is your definition of success, just keep in mind that it's always going to be luck, but it's also going to be your knowledge and your effort. So when that luck strikes, you're able to hold it. And it's precisely what happened to me. I'm extremely honored that I was, tweeted, mentioned to Kent. I was able to convince people that this is actually a good way to mock APIs and we keep making it better. But that may not happen to everybody. And you definitely need to invest into how you promote your project. Make sure that you're solving an actual problem. And that's why it's always a good idea to solve your problem first. Like if you're building an app, what are you experiencing with? Don't solve others' problems because you will never understand them. Solve what you struggle with because you are the target audience. Awesome. You can talk to yourself any point of the day. You can share feedback. Obviously, you will be limited by your experience, but still you are much closer to the problem space that way. So build what solves things for you. And what helped me a lot from technical perspective is, again, setting some kind of limitations, some principles that my tool will never do. For example, MSW will never ship anything specific to any client library. It's not shipping anything for React or Angular or Vue or Svelte, and it works everywhere. And the same way, it doesn't ship anything specific to like React Query or Apollo or any other clients, and it works with them all. It doesn't mean that it's a consequence of this decision. The consequence of that decision is a lot of struggle and hard work, so you can find the proper layer to actually make that principle true. But very often, it will become true. It's just a matter of perseverance. So setting some limitations is a really cool idea, especially when people start opening pull requests. And they're saying, hey, we need to support this. This is amazing. We use it at work. It's going to make the library better. You need to know where the limits of your software lie, because every good software has limits. This defines good software. It doesn't do everything. It does one thing well, or 10 things well, but they still fall in one category. So setting those limits, those principles, helped me a lot as a maintainer to sometimes say no and keep the scope of the project basically sensible, manageable, even while being a single person actively working on it. And yeah, of course, you can take some proactive measures to promote your software, join some maybe Discord channels, talk to people, give talks, small local events, maybe big conferences. It helps a lot. Be proactive in searching for opportunities. And I'm not going to lie, it's going to suck most of the times. Like I can't count amount of forms I filled or emails I sent to companies who use my open source and was ignored, or maybe just, had some generic reply. It's hard. Nobody wants to support open source, but it's very good to see people who do. Like, for example, Sentry did a huge round of support recently. We also got supported by WorkLeap, which was phenomenal. This was out of the blue. It's always nice to be an author of a project and then wake up and see that somebody sponsored you, because they use it in their product. It helps. It brings value. So why not, help keep it alive?
Yeah,
it's very nice. It's going to be a lot of luck and hard work, but hopefully it's worth it.
I love how you talked about the key role of luck, but also the hard work that precedes the luck. So that you said it so I love that you said this. You said when luck strikes, you can hold it. That is such a beautiful statement, because so many of us, luck strikes and we're like, what do we do? And we panic and we drop it. We can't hold on to it. We can't get the most out of it. I've been part of multiple product launches over the early portion of my career where, there was a big countdown and it's going live and there's a lot of anticipation, and then people start using the thing and very quickly it's overwhelmed and no longer available. This happened, to be fair, last week I shipped a hobby project. So I did not cast an expectation of this to be like a big thing. I just said, look, I made this in a few hours. It's a hobby project. I'm talking about Dan GPT. So I created an AI of Dan Abramov that answers questions. And I said, look, it's a side project, so don't expect much. And indeed, that also, like after a few hours, I ran out of money on my OpenAI account because everybody was using GPT 3.5 from my account. And my serverless functions were timing out because of the generation time. So a lot of issues came up, but I did mention it's a side project. And so in case you consider that luck, that a lot of people used my side project, I definitely didn't hold it because, to be fair, there wasn't a lot of hard work that went into making it infinitely scalable because it was a hobby project. But I absolutely love that you mentioned that. Second thing that you mentioned that I think is really valuable here is saying no. So React is, there's a lot of fast ways to build UI on the web. I think Quick at this point in time is the fastest because it ships a deterministic 1 kilobyte of JavaScript on every load, irrespective of the behavior of your application. And so Quick is the fastest, but React is the best. In terms of adoption, literally everything is built on React. We're recording this episode on Riverside. Riverside is using React in production, right? And I think the reason React is so popular is because in the early days of React, it was like that. It wanted to solve for one problem and solve that problem extremely well. There was no scope creep. This is not going to be Angular, where it's a full framework and we have factories and services and routers. And no, we're solving UI updates specifically. We're not solving UI generation. We're not solving routing. And so React was this minimal thing. And of course, there were pull requests like, hey, let me add first-class support for, data fetching. And the team was like, no, we're not doing this. Similar to what you were saying. You have people coming with other client library specific stuff, and you're like, no, I'm not going to do this. I think while I appreciate that you and React and really the great projects have a strong respect for their scope and their boundaries, I'm curious if you could speak a little bit to how you say no, because these issues, these pull requests are raised with really good intentions. Probably they're like, hey, I love MSW. I wanted to work with Apollo, so I opened a pull request and I added a bunch of stuff. And then you meet the contributor with actually I don't want this. How do you do that in a way that's respectable and kind?
Honestly, if I already have a person who opened a pull request, that's a huge win. And what I try to do, I try to get the most out of their suggestion. So maybe what they're suggesting makes perfect sense. We just have to implement it on a different level. So for example, I think we had a proposal to support type document node from GraphQL.gen. So you can use that object as the source of like runtime and type-wise behavior. And of course, like we won't ship anything specific to third-party libraries, but what we can ship is just one TypeScript interface. And if a given object extends it, it's probably type node. So let's infer the types. So my job as a maintainer is to know how to kind of funnel it into the appropriate implementation, if it's possible. And this is very often what I'll try to do. I try to understand the problem. I try to suggest to people, hey, maybe you can do ABC instead. Let's see if it works. And very often, if it doesn't work, very often I would just say, build a community package, build something like MSW-anything. And people do. People already build things for like integrations with Pact. We have integration with Storybook, which was built again by one of the community members. And I believe there's a bunch of examples. Our job is just to give this very simple, very primitive in a way API, and you can iterate on top of it. So if this is what you want, go ahead and build it. If it's a really useful thing that a lot of people can, benefit from, I'm open to sharing it. I'm open to including it everywhere so everybody can use it. And maybe if it's not feasible, you can always fork a project. And I know some people who did. They were not happy with certain behaviors. They just forked them as W. They hack their behaviors there, and it works for them, and it's beautiful.
Great. That's the most open source spirited statement I could hear. I love that you. From what it sounds like, it's never a hard no to contributions because you recognize the immense value that someone actually took the time to make these. And instead of a hard no, it's like, wait, what if we did this other thing? Or what if we changed it this way? Or what if it fit this way? And if it does eventually come to a hard no, it's still not a hard no, because it's like, no, why don't you just fork it? That's fine. I'll even help you with the fork potentially. So I love that. I think there's a lot of takeaways there, because I think this is a skill that we don't know we need in open source. And unfortunately, I've seen way too many open source projects where the responses from the maintainers are understandably so pretty hostile because they're under a lot of pressure. But also there seems to be a lot of entitlement with people opening issues in the first place. I recently saw an issue on SvelteKit or Svelte where there was a person who just was like, I need you guys to fix this one issue of mine. They asked for reproduction steps, and he said, here's the repo. You can clone the repo and Docker Compose up, and you start a database and you add a table. And this was not minimal reproduction. And so after a long argument, he was unfortunately banned from contributing to that repo because of that. So that happened. That's not an isolated incident. That happens a lot. And what I'm hearing from you, what I think all the listeners and I are hearing from you, is there is a better and more constructive way. And I appreciate you for highlighting that. Let's talk. Let's wrap up. But I want to talk about actionable ways we can all add more high quality automated testing to our projects. Okay. We talked earlier about the pressure of business requirements and, I need to ship, so I'm going to leave off the test. You mentioned, actually, if you add the tests, you can ship faster because you're not like scrambling for QA at the last minute. That said, I'm wondering if we can talk about some actionable ways developers can sort of balance both worlds. Like they can ship fast, but they also balance a high level of quality automatic testing. What if there was a middle ground there? What would that look like to you?
So I think teams and different developers will find themselves in different situations. But what would work, I think, every time, we'll try adding a test. That's basically my advice. If you think most likely your project is missing tests, so try adding one. Try adding a test for something you know how it works. Try adding a test for something you're building right now. Of course, depending on you need to be honest with yourself. If this is your first time writing a test, maybe diving into, end-to-end tests and database mocking and like everything else will take you 3 years. You need to be realistic, but it doesn't mean that you cannot bring value. You can still write meaningful tests. You can maybe extract a part of your logic, make it a unit test, make it a function that you can cover. Any test will give you value as long as it fulfills the purpose. And we already touched on that. The purpose of test is to verify the intention, is to validate the intention. Even if you validate the intention of a small thing, that's already one useful test. And you end up in a good place by accumulating those useful tests. They can be small and focused at start, and then they can grow to be like huge test suites with like end-to-end tests or integration tests. So definitely just start from somewhere. Don't be afraid. And as you go on, just keep the torch, keep carrying it, and keep testing stuff. Definitely some things will be harder to test than others. Invest into testing setup. Or if you may be unfamiliar, then raise this topic with the team. Because a lot of people miss testing setup, how do you, like, I've been in the situations, even like testing for like 5 years, 6 years professionally. And I found the situations when you take the code and you know how to test it. You see the test in your head. But once you write it, you realize this code connects to like 10 different things, which first you don't know about. Maybe you joined the project a week before, or like 2 weeks before, a month before. You may not touch this area in a year, depending on the scope of the project. And suddenly I have the test, but it misses the orchestration. It misses the setup. I have the test. I don't have the box where I can put the test so it runs. And this is where like I encourage people, especially if you're like CTOs or senior engineers, take a look at what you're building and take some time off to basically contribute to the testing setup. Make sure that when people join and they want to write tests, they have all the tools you need to write the tests. You have your mock database controller, or whichever way you decide to approach that. You have your testing utility, so you don't have to, repeat these blocks of actions in every test. You have like util. Something. So, yeah, start there.
Awesome. What I'm hearing is, when in doubt, write a test. Write a small test. Write something, and something is better than nothing. I guess then, to extrapolate, the healthy middle ground from I need to ship immediately to I'm going to spend all of my time writing tests. Those are two extremes. The solution is write some minimal test that is possible within. So I guess a practical exercise we can do is analyze, okay, I've got this much time. I need to ship by this date. What's like an MVT, right? What's a minimum viable test suite that I can get started on? Does that track with what you said?
Definitely. But of course, if you take time into consideration, the tests that provide most value are always end-to-end tests, or even like smoke tests. So because we touched on this, the more of the real system you run in a test, the more value you get. This is the actual code that will run for your users. You can invest, like if you're comfortable with testing and you have a strict deadline, then write those like 3-5 end-to-end test scenarios that are critical to your product. I don't know, checkout works, cart works, registration works. They shouldn't take you that long to write, because end-to-end tests usually don't need that much setup. You have the browser covered. You have most of your code executing as is. You want that. Maybe you have to cover some third-party interactions. For sure, reach out to tools like Knock or MSW and have those critical paths covered reliably. Definitely something I would do, because I don't understand how you can ship something without knowing that it works. And the only way to prove that it works is to have a test. It's the hard truth. I have a quote that I usually say when people debate JavaScript versus TypeScript, but I feel it also fits here very nicely. Like writing pure JavaScript without tests, for me, it's like trying to cut a watermelon with a chainsaw in a dark. So I genuinely don't understand. I know a lot of people see a lot of freedom in that, and I respect that. But you also need to acknowledge that you don't have to have the lack of familiarity and knowledge stand in the way of better software. Well, so if you can improve, do it.
Well, can I push back on that a little bit? Because you say, How can you ship something without knowing it works? But in some cases, manual testing tells you it works. You write your feature, you use your feature, you go like, you know what? This is doing what I want it to do. This is doing what the product owner says it should do. It works. So I guess maybe a lot of the people who don't test as much, maybe the understanding of quote unquote it works is not the same. So I guess maybe can we speak to that a little bit? Like what do you mean by it doesn't work? Is manual testing not enough to verify that something actually works?
Manual testing is great and very useful in some situations. It's still part of testing. There's a phrase, like there's a word test there. The problem is sometimes it's time consuming. And the biggest problem is, okay, it works right now for you here on this branch today. How can you make sure it works tomorrow? How can you make sure it works in a month? I mean, unless you're building something that will not be there in a month, which is not the intention for most software. We do want our ideas to succeed. We want them to get traction. We want people to love them, or depending who depending what the target audience is. So how do you prove that it keeps this common ground, that it still works? Well, you do that through testing, unless you want to go manually through all the behaviors every time, but nobody does that.
Right. And then that's why things break down over time through unexpected regressions. Okay, so if I dare augment your sentence, what I heard, or if I could rephrase it, I would say you would say, how can you ship something that you don't know works reliably every time in every circumstance? That's probably what you were saying, right? Because manual testing will tell you that it works, but it works like now in these conditions and only now, and it may not work 5 minutes from now. But what you're talking about is, how can you ship something that you don't know like works every time reliably? Yeah, okay, I see that. And the answer to that, of course, is testing. In closing, you mentioned the future has got its tests passing. Would you care to comment a little bit about the future of testing, both unit integration end to end and with your Epic Web work?
Yeah. I think the future is making testing more and more accessible. By that, I mean having more and more people understanding what it is and what it's for and being able to pick it up. Even if they don't know everything, nobody knows everything. Even if they write bad tests at first. I wrote a ton of horrible tests, but you never get there unless you keep trying. So make it more accessible. I do believe in JavaScript, we actually have testing quite accessible. We have amazing tools. We have tools like vtest and Playwright. They make our lives much easier. So there's no excuse not to dive into automated testing, not to write good tests. And it will be difficult and stuff may break and stuff may be flaky. And that's fine. We will learn to handle that. We will learn different strategies in testing. But I do want to see more people adopting this, more people talking about testing strategy. Like there are so many teams who just develop stuff and they have no testing strategy in mind. How are we going to test this? Are we even going to test this? Maybe we're going to test this like in 2 years when we get another round. I don't know. Maybe that works for them. I think it doesn't. I think what works much better is understanding that software is an inseparable part of testing. It's what brings quality to what you write. So that's precisely what I will try to do. I will try to write and talk and record a lot of stuff on testing. So it will be relevant to people who try to test or who have been testing for years. This is why I joined Epic Web. And I really hope that I will be able to make testing more accessible to people.
Awesome. Well, Artem, I really appreciate this entire conversation. I mean, we started talking about my own inadequacies and how I don't test things and how maybe I should. We talked about MSW. We did quite a deep dive. We talked about like the node networking stack and your knowledge there. I have not heard anyone else speak that way about the deep inner workings of the node networking stack. And really even just the whole motivation to create something like MSW. Yes, to share it with your friends, but also I don't want to change my implementation because it feels wrong. From beginning to the end, you've been nothing less than an absolute treasure trove of information in and around automating testing, open source, and so much more. And for that, I want to thank you so much for coming on the podcast and sharing your insights with me and all the listeners. Thank you so much.
Thank you for having me. It's a great honor. Thank you.
Thank you for joining my discussion with Artem Zakharchenko. I hope you enjoyed it as much as I did. And I really did enjoy it. Like he shared so much in such a kind and humble way while correcting me where I was wrong and really outlining the best way to take part in automatic testing and get the most benefits out of it. If you're learning from and or enjoying this content, I'd invite you to leave up to a 5-star review on Apple and or Spotify. And if you're on YouTube, maybe like the video, subscribe to the channel. And if you're on anything, maybe share it on social media. All of this is just a signal to me that what I'm doing is valuable and if it's worth spending more time on. This podcast is an experiment. And if there's not that much benefit, maybe I shouldn't do it. And I'm not like threatening to stop. I genuinely am a fan of giving you value. And if this is not valuable, then I need to know and so on. So I'd encourage you to do that. And finally, thank you again to the sponsors. That's Codecrafters. If you want 40% off, there's links in the show notes, tej.as/codecrafters. I'm really thankful you're here. I'm thankful you're a part of this podcast. And thank you for your interest in engineering.